All right, we're going to go ahead and get started. It's 4:20. I think I have 40 minutes of your time here. So let's dive in and learn Kubernetes Gateway API to control and secure Ingress, Egress, and mesh traffic. So I will start with, come on in, we just get started if you are. I will start with a quick introduction of myself. So this actually feels very close. I normally travel to much further than this. So I'm from Raleigh, North Carolina. I've been living there for 26 years. I work at a small company, Solo.io. How many of you know of a small company? Well, a few of you. So I'm the head of open source at Solo.io. I also serve a bunch of open source roles in the community. I'm a maintainer on the Istio project, also maintainers on the Kgateway project, and maintainer on a K-Agent project. So all of the three projects are part of the Cloud Native Computing Foundation. So how many of you know what CNCF, Cloud Native Computing Foundation, is? All right, pretty much most of you. Makes sense because this topic is cloud native related. My talk is actually going to be mostly demo. So what we're going to do together is, I have to confess I'm not very well prepared for this demo, but I've run this demo multiple times, just not for this particular talk. So please bear with me if we need to troubleshooting something together, let's do it together. I think many of you probably already have some experience with some of these technologies or projects out there. So we're going to use a generative AI application I wrote, which is using Python, and it runs as a web application, which I power the web application with Streamlight, which is the second logo. Kubernetes is where we're going to run our generative AI application. So we're going to have the application running initially in Kubernetes without any traffic control, without any security. And then we're going to introduce our application to be controlled by Ingress Gateway, which allows the application to be accessed outside of your Kubernetes cluster. And we're going to use the Gateway API to do that. How many of you are familiar with Kubernetes Gateway API? All right, many of you already. I guess that's why you are here. And we're going to use Prometheus and Kayali to help you visualize the application, to look at the metrics if we have time. And then we're going to use K9s to help us visualize our Kubernetes cluster. I'm using a simple flat node CNI because it's all running on my laptop. I'm sure you're probably using a more complex CNI, but the technology I'm introducing here would be compatible with other CNIs out there. And then for the identity of the services, we're going to use Spiffy, which is the standards to handle identity inside of Kubernetes and cloud native application. And we also use Argo to roll out deploy the application to the Kubernetes cluster. Since I'm using a generative AI application, I use Llama, which runs locally on my machine, and we're going to be able to use Llama to do a little bit of fun exercise. So that is a quick overview of the demo, and I do have the repo here if you're interested. Then we'll start with showing you my Kubernetes cluster. Before I show you that, I just want to quickly show you, this is my Argo application for the generative AI demo. You can see it in the back, right, folks from the back? Okay, just let me know if you ever need any funds increase. I'm happy to do that for you. So the repository is pointing to the repository I just mentioned to you, by the way, which is right here. And the folder is configured to the Kubernetes path in the repository. And I'm configuring to my local Kubernetes cluster. As you can see, I actually just created this Argo application this morning. And you can see it's synced to the latest of repo. I can sync it again too. Just so you know, for the purpose of the demo, I'm doing manual sync. But typically, you actually do automatically sync. So whenever there is a a change in your repository of GitHub, it would automatically propagate the change to your production environment or whatever your Kubernetes cluster is. And then just quickly review my Kubernetes folder in this GitHub repository. I have a very simple client application, which I'm not even sure I will use it, but the core application is this demo application. If you are familiar with Kubernetes YAMLs, this is composed of a deployment service, and it's linked on my demo application version 2, which I will show you shortly. And I was learning generative AI, as many of you are out there, so I end up developing a RAG module, the service for my generative AI application. So I have a version 1 of the RAG service. I also have a version 2 of the RAG service, which basically it has an enhancement of on top of version 1. The only difference is the version 1 can only allow user to upload a PDF file, and the version 2 allows you to upload not only a PDF file, but also a TXT file. So that is the demo application. And this is the application deployed in my Kubernetes cluster in the default namespace as demo, RAG, and version 1 and version 2 through that Argo application. So I don't have to manually deploy myself by syncing from the Argo application. It's already out there. So now, if I want to access my demo application, let me show you a simple way to test is I can set up port forwarding. I can access it right here. So did you notice if I set up port forwarding? I think it's on this port. So correct me if I'm wrong, if you guys spot anything I did. Like I said, this is very much unscripted. So the first thing I can just to quick show you what the application is. I can ask what are top 5 things to do in Denver. Hopefully it would respond. So what it's going to do is going to ask the large language model, which I have it here, Llama, and I have a model loaded in Llama to allow me to chat with conversation style. So finger crossed this is going to work. So what it's going to do is this demo application going to chat with a llama on this Lava model, and it's presented on 5 fun things to do in Denver, which I hope some of you actually had a chance to explore. And honorable mention. All right, I guess plenty of things for us to do in Denver. So this is the simple application, but that's not the topic I want to show you. This hopefully sets the stage of, let me disable the port forwarding if I remember the command. I think I can disable, so I want to disable the port forwarding as Control D here, yeah. All right, so I'm going to delete the port forwarding because typically you don't access your application through port forwarding, right? I only showed you because I want to show you the application without the Ingress gateway so you can see what it looks like. So in order, the next thing we're going to do together is we're going to deploy a Ingress gateway, and we're going to configure HTTP route, so when the traffic hits on the Ingress gateway, it knows to route on this particular port number or this particular path, it knows to route to my demo application. So envision if I'm running this demo application in a cloud provider Kubernetes environment, I can have all the traffic controls through the Ingress gateway, right? So that's typically what a production environment looks like, or you could even front your Istio Ingress gateway with a cloud load balancer. So in order for us to do that, the first thing we're going to do together is we're going to deploy an Ingress gateway together. So hop onto policy here. Let me increase the font a little bit so folks can see better. So we're going to use Istio Ingress Gateway in this example, but notice I'm using very generic gateway resource here. So this given resource, when you change to a different class of the gateway, you can easily deploy it to, maybe it could be Kgateway, or it could be Kong, it could be any other implementation of the Gateway API here. But for this demo, because I already set up, it's still on my environment. So let's go ahead deploy a Gateway resource for Ingress Gateway. And for me to deploy into that, what I'm going to do is, I'm going to make a copy of this policy file, Ingress Gateway, right, to my Kubernetes folder. So which means hopefully through here, actually I need to add to my Git too. So sorry, I think it's this command. Okay, so we're going to add Ingress Gateway, right? So that, okay, did I jump more? Okay, so I had a couple of other changes, but hopefully this is the only change that Argo cares about. So I have this pushed, right? So what I'm going to do, by the way, I'm getting a connection error because I disabled the port forwarding. So what I'm going to do is I'm going to click on the sync button, which hopefully would push the latest change. What did we do together, right? We deploy Ingress Gateway, and let's see if that Ingress Gateway is deployed. All right, so this is our Ingress Gateway, so it's deployed. But now this Ingress Gateway won't do anything, right? Because we don't have any route configuration deployed, config this route. So what we are going to do next is we're going to config HTTP route together so that when the traffic goes to the Istio Ingress Gateway, which we just deployed together, and when it goes to the port number, the standard ports, and goes to the slash, can the Ingress Gateway help us forward the traffic to the demo service? And we're going to deploy that in the default namespace. And the reason we can deploy that to the default namespace is because the demo is also running that namespace, but you don't have to. So I was just talking to this gentleman at the front before my talk started. This is a good model. Well, as an admin, you can say, you know, I want this particular path to be controlled by the default namespace, and then the developers or the engineers who owns the default namespace can own the HTTP route in this case and configure the route accordingly, right? So we reviewed this together. What I'm going to do next is I'm going to copy this files. I think it's called demo, to my Kubernetes folder, and then we are going to add this. Is it -p or -dot? Okay, so it is dot. So hopefully it picks up the change. Add route. Okay, so it did detect the change. Okay, so now we push this change to the latest of the repository, and if we hit the sync here, which hopefully would deploy the HTTP route in my cluster. And if you do a HTTP route here, that would allows you to view all the HTTP routes in my environment, and I only have one here. And you can see, one thing I love about Kubernetes Gateway API is you get to see the status field. So you can actually see if your route is valid and if it's accepted and all the references are resolved. So this gives you the confidence that your route is going to work. Prior to Kubernetes Gateway API, if you ever had how many of you had actually had an experience with Ingress? So you know sometimes it can be a little bit harder to debug because without the status, you are kind of rely on logs a lot of the time, right? So now what we're going to do next is we're going to try to access the demo application from Istio Ingress Gateway. So since I'm running everything locally on my environment, so I'm going to set up port forwarding on my local ports. So local ports 8888 is going to forward to Istio Ingress Gateway. So let's see if that works. So normally you don't do that with the cloud provider environment, but this shows you how you could potentially set up the traffic access through Istio Ingress Gateway. All right, so you can see this is my demo application. It's the same application, but now I'm reaching it from Istio Ingress Gateway. So I'm going to ask, what is Istio Ambient Mesh? So this is a new service mesh concept we introduced in the Istio community 2-3 years ago. How many are familiar with it? All right, a couple of you. So, and I'm going to rely on you to actually tell me if the response from the AI makes sense. So 2 of you. So it's a feature in Istio, allows sidecar injection without the need for a dedicated mesh. It enables Istio to function in environments where a full-fledged mesh. What do you think? Yeah, it's not right? So you can see this is the experience when you interact with the AI. Sometimes the AI may make sense. I think it gets the Denver question pretty well. But this one, you know it's wrong because when we introduce the Istio Ambient Mesh, the key point is you don't need sidecar for service mesh, right? You're trying to resolve that specific pain point we had on Istio, and you know the first sentence was wrong. So, so that's not great. And that's why when you need RAG sometimes. So in order for us to use RAG, I'm going to progress a little bit more here. I'm going to add our services into mesh, ambient mesh in this case. So in order for me to add my services in the default namespace into ambient mesh so that I can control traffic for inter-service communication, like the communication between demo to RAG, so that we can showcase what Istio Ambient Mesh is through the RAG module. So in order for me to do that, it's actually really simple. And correct me if I'm wrong for 2 of you who already know ambient. So all I need to do is I need to label the namespace with data plane mode equals ambient. So that's all I need to enroll all the pods in the default namespace into ambient. And the other thing I'm going to do is I'm going to also deploy a waypoint proxy in the default namespace. And the reason I want to deploy a waypoint proxy is a waypoint proxy, you can think about it as a micro gateway for my namespace or whatever tenant scope you feel comfortable. In this case, I'm using namespace as my tenant scope, and you can use that waypoint proxy to control the traffic within your namespace or come into your namespace. So you can see we can use apply command to apply. And so I'm going to run this. And I'm going to enroll my namespace to leverage, I think it's called, let me run a help. I think it's called enroll namespace. Okay, so what I'm doing is not only I'm deploy a waypoint proxy into my default namespace, I'm also label the namespace with use waypoint to use the waypoint that was just deployed, and this was the waypoint that's deployed. By the way, I don't need to restart any of my application or pods because Istio Ambient enables you to run your application without sidecar. So we have a waypoint deployed in the default namespace. In the meanwhile, if you notice, let's see, I think I have, did I have, egress. Let me do a namespace check on here. Okay, so I also have an egress namespace here, and this is just a normal namespace, which I want to enroll this namespace to ambient. I also want to deploy a waypoint into that so I can control the egress traffic. So in order for me to do that, I'm going to put the Istio egress. Is that the namespace? All right. Okay, so this one already have enrolled the namespace. So basically it means I had this label already on, so it doesn't need to be re-enabled. And I'm also going to do the label namespace command on the Istio egress as well, so that I can enable the egress waypoint also into the ambient. All right, so we did a bunch of setup to enable us to control traffic for inside of the mesh and also control the traffic to external to the mesh. The next few things we're going to do, I'm going to review this together with you, is we are going to, first of all, control a route configuration to route the traffic from the demo application or any application to our RAG service. So in this route, you can see we are using the same HTTP route we reviewed together, but this is a route for RAG HTTP route, and the route is applying for the RAG service instead of using on the Ingress gateway as previously. And when the traffic hits on the route, on the RAG service on /path/, we're going to allocate 70% of traffic to version 1 of the RAG service and 30% of the traffic to version 2. And if the traffic has the canary equals true as the header, it's going to always go to RAG version 2. So let's go ahead enable that by copy this RAG route, I think it's called, into our Kubernetes. And the other thing I want to, just to save time a little bit, I want to also show you how I control traffic, who can access through the egress waypoint to my Alama, which is, I told you all, I'm running Alama locally on my Kubernetes cluster, which is, outside of my Kubernetes cluster, but also in Docker. So this is why I'm accessing Alama using host.docker.internal on this ports of Alama. So what I'm going to do here is through a service entry resource, I can control traffic from inside of my cluster, access to Alama, go through the waypoint, the egress waypoint that we set up together in the Istio Egress namespace. All right, so what we're going to do is we're going to copy the service entry also to our Kubernetes, and we're going to do commit, add RAG and service entry, and we're going to push it to our GitHub. So now that we push the latest change to our GitHub, and we're going to sync, it already recognizes out of sync, which is nice. So we're going to try to sync it together. And if we go here, and if we go to HTTP route, so would you expect us to see, I think I had a typo, so let me type it again. Somehow it was all uppercase. All right. Well, it's because it's scoped to the namespace. So you can see the RAG HTTP routes is already in my system. Let's see if it's accepted. So you can see this is exactly what I reviewed to you before, right? 70% to version 1 and 30%, and the route is accepted. Okay, so that looks good. So let's go ahead and try the routes. So the demo application is still here. And then we're going to use the RAG demo. So the RAG demo allows us to upload a file. I remember, if you recall, we mentioned together, version 1 can only take the PDF file, and version 2 can take both the PDF and TXT file. So in order for us to, we're going to try to educate what Ambient is to our large language model through RAG. So I'm going to try to upload the file. So you can tell right now, because it hits version 1, right? So it's getting an error. Now, if I do it again, so hopefully, well, it's still version 1. Not surprised, right? We config 70% of traffic goes to version 1. So now it actually took it, right? So, well, we did it 3 times. So that's roughly about 67%, which is what we configured to do, right? So this is great. But if you feel happy with version 2, then what you want to do is kind of promote your traffic to version 2, right? And to promote your traffic to version 2, you can do it very, very easily by just changing this to 0 and change this to 100%, right? So that's how you control the traffic through Kubernetes Gateway API. Does that make sense to you? All right, so let's make that change so that we know it always goes to, let me make sure I save it here. I did. Sometimes, when you make changes, especially on stage, you forgot to save it. I think, did I got it right? Is it in the Kubernetes folder? Let me double check. I thought it's in the policy folder. Right, okay, so I'm glad also we wouldn't have the change in place. All right, so now we're going to move to the Kubernetes folder, so it has the latest, right? Now we need to do Git, and then you can review the changes we did together. And, oh yeah, we also made a change to the policy. Okay, so update rag route and push. All right, so hopefully this has the latest change. And then we're going to use Argo to sync the latest change. So this is actually why I do manual sync, because I think there's a sync interval. Like this time, it didn't detect I don't have the latest. All right, so if we jump into the HTTP route here, and wow, that age doesn't look too good. So hopefully it's refreshed. All right, it's refreshed. I was worried because the age was 3 minutes old. Okay, so if it's refreshed, now when we go here, we should always hit 100%, finger crossed. That's the magic of the waypoint proxy, right? It helps to control all the traffic goes to the rack service, so I can control whether it's 50% or 100% to the new version. So, all right, so let's do one more time, just so have the confidence you can see it's all successful. Now, let's ask us the question, what is Istio Ambient Mesh? And hopefully with this time, it can answer the question because, huh? What? I did upload. Right, so basically when we upload the TXT, it has the TXT stored in the vector database, which is running as part of the RAG module. And then when I ask the question, it knows to search the vector database to find the answer. So you can see the answer is pretty accurate now. It also gives you the source on where to find it. So that's the magic of why sometimes you need to redefine your data using RAG, because generative AI sometimes just make up the data for you, especially on newer concept, right? Okay, so we showed you how to control traffic routing through Ingress. We showed you how to control traffic inside of your namespace or inside of your mesh. We also try to control traffic through a service entry that allows you to control traffic outside of, from your cluster to outside of your cluster. Let's visualize our application together. And in order for us to visualize our application together, I'm going to make sure, so we do have the Kayali dashboard, which is a dashboard for Istio. And I believe this is listening on port 2001. And let's see if we can visualize the traffic graph together by selecting the namespace. I'm going to change this to last 10 minutes or 30 minutes when we did the demo, because sometimes it shows a little bit more. And I'm also going to animate the traffic. All right, so this is our demo application. Basically what I showed you, so we can visualize. Can you see it in the back? Good? All right, so what we did was from the Istio Ingress Gateway, when the traffic comes in, it hits the demo application. By the way, you can see because I'm running everything inside of Mesh, all the traffic is secured, and you can see it's secure with the source and destination principal in this case. We also get TCP metrics. I believe we also have HTTP metrics as well in this case. So you can see it's all green, right? The traffic from Ingress Gateway to demo. And then from the demo application to the RAG, we're getting a lot of error, right? Because I tried to upload a bunch of TXT file. The RAG version 1 couldn't handle, so we're getting a lot of 400 error. And from the demo to RAG version 2, we got a bunch of success, right? Because that's the one can process the TXT file. The other thing really interesting here that I want to show is we are also having traffic into the external Llama because the fact I'm running the egress waypoint, so I gained visibility on who is accessing the external Llama or any external services as part of controlling who can, what can access. So you can see through Ingress Gateway control incoming traffic to the cluster. Through this waypoint proxy, I can control traffic coming into my namespace. In this case, it's through the RAG. And then through the Istio Egress waypoint, I can control traffic coming into my external services. One other thing I want to show you, does anyone have any questions, actually? No? All right, so one other thing I want to show you is you can also apply authorization policy on your services. Like in this case, we're going to apply RAG authorization on the RAG service. So we're going to say for this particular RAG service, we're going to allow post and get on /query. But not on anything else. So if you remember the RAG service, the /query is when I ask the question, and then when I upload the document, it's /upload. So this would allow anybody to /upload if it's working properly. So with that, I'm going to copy the policy file. I think it's called auth to my Kubernetes folder. And I'm going to git add this and commit this. All right, and then I'm going to push it back to my GitHub repository. And let's sync this to my cluster. Sorry, I pressed on the wrong button. All right. As you can see, the sync happens pretty fast, so we should have authorization policy if it's working here. So I should still be able to ask a question, but now if I try to upload that TXT file, you can see it's not allowing me to do that. And if you look at the waypoint proxy in the default namespace, which is the one that's enforcing the auth policy, you can see I'm getting a 403 RBAC denied, and the 200 is it's for the query because we still query this for what is ambient mesh. So that means query still works, but this communication on any other path other than /query, other than post or get, is going to get 403 RBAC access denied policy. So you can see through authorization policy, you can use you can do pretty much reach layer 7 type of authorization policy on the waypoint proxy without needing to deploy a sidecar. And I know I was talking to you early on plugging external RC and maybe using OPA. So that's one of some of the more advanced example you can tie into authorization policy and using JOT. So that's all possible using a waypoint proxy. Let's see, what else I want to show. We talked about Prometheus before, so let me show you Prometheus quickly. So I think I have Prometheus running. So in order to have Prometheus running, gosh, I need to remember the Prometheus port number. And Prometheus have three, Prometheus have three, okay, I don't think I can remember the command very well, so I'm going to use this handy command. I think it's the Kado dashboard Prometheus. Okay, so essentially that command is doing the port forwarding command for me because I don't remember the exact port forwarding. And Prometheus container, unfortunately, I think it has like 2 or 3 containers, so you have to make sure you're port forwarding to the right containers. All right, so this is our Prometheus metrics. So we talk about you can see the TCP metrics by adding your pods into Ambient and also having the traffic mediated by the Ingress gateway and having the traffic mediated by the Egress gateway, which is a waypoint we see. So you can see this is the traffic from Ingress gateway to what's the destination? Let's see, this is the source. Sorry, this is a lot of data. Okay, so from the Ingress gateway to demo, and this is from the demo to, I think, to the waypoint proxy, right? Actually, this is from the demo to the egress waypoint. And this is from, let's see, this is from the waypoint proxy to, what's the destination? To the RAG. So that's how the waypoint proxy can mediate the traffic going into the RAG. So you can see it's a bunch of metrics, probably more than what you need. And that's layer 4 metrics. You can also get access to layer 7 metrics. In this case, we can see layer 7 metrics such as Istio request total. So that's all available for you. And by the way, that's how we were able to build a complex dashboard like this, because through the metrics we collected on TCP and HTTP, the metrics can help us render a complex dashboard so you can easily visualize your application in the mesh nicely. All right, I think that's pretty much what I want to show. I'm going to take a pause here, see if any of you have any questions, because I think we kind of discussed control traffic, secure traffic from Ingress to intramesh traffic through the waypoint proxy, and then control the access to external service through egress traffic. So anything else you guys, go ahead. That's a great question. So I think the portability and the easy config using YAML and rely on the infrastructure to do that. This is why, instead of having each individual developer to innovate on how am I going to get my spiffy identity from my certificate manager or Spire, how am I going to do mutual TLS, how I'm going to upgrade my connections through mutual TLS, and how am I going to, enforce my policy through my application, right? You could do that in all of your application, but the problem is your application developer would have to do a lot of work. You have to kind of combine the business logic of your application with some of the infrastructure component. And if your team writing your application in multiple languages, then they have to do it in different languages. So I think it's a lot more with now through simple policy and standards. By the way, the Kubernetes Gateway API is very, very portable. Like the HTTP route here, what I'm doing is very portable. You can use it on other gateway API and gateways. The authorization policy, this is standard in Istio, but we're looking at standard in the Kubernetes community as well. So I think it allows you to move very easily and portable through different providers as well, and simplify your application so you can focus on the business logic of your application, if that makes sense. Does anybody else wants to add and weigh in on this topic?
Enterprise authorization policies.
Yeah.
As opposed to the application
Yeah, and the other thing is, think about in your organization, there may be somebody who's in charge of like configure authorization policy or OPA policy, and they want visibility. They don't want to dig into your application code to figure that out. So you get more policy control, and for auditing purpose, I feel you get a lot more visibility into what you're doing too.
I get concerned about like if we're, I mean, Kubernetes isn't going anywhere anytime soon, of course, but you know, if we're using something that is Kubernetes, like, is that actually usable for other stuff? But you just explained it is. This is very much a standard for other things.
Yeah, I do think it's very much standard. I think Kubernetes and cloud native ecosystem just reached 10 million users, which is like a huge, yeah. It's like Kubernetes is pretty much the operating system for cloud native, right? So yeah. And with the movement of generative AI, I do think more people are going to write the cloud native and the faster iteration type of application. So you're not dealing just your legacy application, which you're still trying to think, do I need to move to cloud native or do I just continue with my monolithic, right? With the move of generative AI, people trying to write agents, I think people will adopt the more cloud native application way more, yeah. Great question though. All right, I think we're right on time. If anybody have any further question, I'm around. Thank you so much for sticking last session of the today. I really appreciate it. Thank you.